Welcome to another episode of the Data Science Dossier Unwrapped, a podcast that delves into all things data. In today's episode, we'll be exploring the world of data lakes and how they can revolutionize the way organizations store and manage their data. This episode is specifically tailored for data scientists looking to optimize their data storage practices, so let's delve right in. To kick things off, let's start by understanding what exactly a data lake is. A data lake is a centralized repository that allows organizations to store vast amounts of structured and unstructured data in its raw format. Unlike the traditional storage systems, data lakes are designed to accommodate data in its native form without the need for predefined schemas. By doing so, data lakes provide flexibility and scalability, making them ideal for those who need to work with diverse data sets. One of the key benefits of using a data lake is the ability to store data from multiple sources, such as social media platforms, IoT devices, and customer interactions, all in one central location. This enables data scientists to analyze and derive insights from a wide range of data without the limitations of siloed systems. It's imperative to appreciate the evolution of data storage and management that led to the advent of data lakes. Think of it as a major leap forward from rigid, structured databases that constrain your data potential. Data lakes can be compared to actual lakes filled with different types of data streams flowing in, such as tributaries. The structure enables you to store unlimited amounts of data from various sources in whatever format it comes in, structured like SQL, semi-structured like CSV or JSON, or unstructured like emails or documents. With no need to classify data upon entry, you can store it as is, and hence the term raw data. This approach provides unprecedented agility and flexibility, allowing data scientists to structure and analyze data in diverse ways tailored to the unique needs of their explorations. This is the essence of a data lake, a dynamic, versatile, and powerful element within a data scientist toolkit. Now that we have a clear understanding of what a data lake is, let's delve into the steps involved in setting up a data lake. Process can be complex, but by following a systematic approach, organizations can ensure a successful implementation. Step one is to define the objectives and use cases for your data lake. This involves identifying the specific business goals you hope to achieve and determining what types of data will be stored in the lake. Step two is to design the architecture and infrastructure of the data lake. This includes selecting the right technologies and tools to support your data lake, such as cloud-based solutions or on-premise infrastructure. Numerous tools and services are available on the market to manage your data lake effectively. Amazon Web Services is a prominent player, offering Amazon S3 for storage and Amazon Redshift for data warehousing. In addition, AWS Glue provides a serverless data integration service that simplifies the discovery, preparation, and combination of data. Microsoft's Azure is another key contender. Their Azure Data Lake Storage combines the capabilities of both blob storage and data lake. It offers a hierarchical file system as well as the advantages of blob storage, like low-cost tiering and data lifecycle management. Google Cloud Platform, GCP, has a competitive suite of tools, including Google Cloud Storage for storing data and BigQuery for analytics. With these tools, GCP offers a robust and cost-effective solution for data lake implementation. Lastly, but certainly not least, Databricks is a unified data analytics platform that provides collaborative notebooks, integrated workflows, and a runtime optimized for the cloud, making it another worthy choice to consider when managing your data lake. So these are just a handful of examples, and the right choice depends on your specific needs and existing technical stack. It's important to evaluate each option thoroughly, considering not only the capabilities of the tool, but also its compatibility with your organization's objectives and resources. Step three involves data ingestion, where data comes from various sources, is collected and loaded into the data lake. It's important to establish robust data governance practices during this step to ensure that data quality and integrity is maintained. Data ingestion is a crucial part of establishing a functional data lake. There's a variety of tools that can assist in this process, each with their own strengths. For example, AWS offers Kinesis, a platform that facilitates real-time data streaming and ingestion. Azure, on the other hand, provides Azure Data Factory for ETL processes, which can pull data from a wide range of sources. Google Cloud's Dataflow is another option, also known as Apache Beam for people in the open source world, providing both batch and real-time data processing. Databricks also has a multi-purpose tool in the form of Delta Lake, which works with both batch and streaming data. These examples cover the main cloud providers, but there's also independent offerings like Apache NiFi and StreamStats that can provide robust data ingestion capabilities. As always, a selection of the right tool should take into consideration your specific requirements and compatibility with your current tech stack. Finally, step 4 is to implement data security and access controls to protect sensitive information stored in the data lake. This involves establishing authentication protocols, encryption measures, and monitoring mechanisms to safeguard the data. As with any specialized field, data lakes come with their own set of specific terminology. Let's take a moment to clarify some commonly used terms in the context of data lakes. First, we have ingestion, which refers to the process of batch loading data into the data lake. It can involve batch processing or real-time streaming, depending on the nature of the data being ingested. Another important term is schema on read, which means the data is not required to conform to a predefined schema before being stored in the data lake. Instead, the schema is applied when data is accessed or processed. As we delve deeper into the world of data lakes, we encounter the concepts of bronze, silver, and gold layers. And these terms, popularized by Databricks, refers to the stages of data refinement within a data lake. Bronze layer, also known as the raw layer, is the initial landing point for data in the lake. Here, the data remains in its raw, unaltered state, providing a comprehensive historical record. Moving up, the silver layer is where data is cleaned, enriched, and conformed to a structured format. This intermediary layer, often referred to as the trusted layer, serves pre-processed data ready for analysis and consumption by various business intelligence tools. Finally, the gold layer contains business-level aggregates, also known as the most valuable data. This data is fully processed, optimized for performance, and ready for direct business consumption. Data in this layer is typically used for reporting, dashboards, and decision-making. Understanding these layers is crucial as they provide an organized structure, ensuring the data lake users can easily locate and utilize data in its appropriate form, and thereby deriving maximum value from it. Lastly, data governance plays a crucial role in data lakes. It involves establishing policies, procedures, and controls to ensure data quality, privacy, and compliance. Setting up and maintaining a data lake can come with its fair share of challenges. Let's discuss some of the common hurdles and explore some potential solutions to overcome them. One challenge is data integration. With data coming from various sources, ensuring seamless integration can be complex. Implementing data integration tools and frameworks can, of course, streamline that process. Another challenge is data security. With large volumes of data stored in a central location, organizations must prioritize data security measures such as encryption, access control, and regular security audits. Diving deeper into data security challenges, we find that there are several potential hazards to consider. Firstly, unauthorized access can pose a significant threat. Without proper access controls, sensitive data can fall into the wrong hands, leading to potential misuse or worse, a breach. A second hazard is data leakage, a risk heightened by the vast amounts of data stored in data lakes. Even small leaks can lead to significant losses, both financially and reputationally. Additionally, the integration of data from multiple sources can inadvertently introduce vulnerabilities or corrupted data, compromising the integrity of the data lake. That's why it's key to implement robust security protocols such as two-factor authentication and advanced encryption methods, and continuously monitor potential breaches. Regular audits, updates to security systems are also essential to maintain the security posture and ensure compliance with privacy regulations. Lastly, organizations often face challenges related to data governance. Establishing clear data governance policies and procedures, along with ongoing monitoring, can help mitigate these challenges and ensure compliance. Data governance in data lakes typically involves several key policies to ensure data quality, accessibility, and security. Data quality management is a fundamental policy that focuses on continuous cleaning and enrichment of data to maintain its accuracy and relevance. This includes removing duplicates, correcting errors, and verifying the integrity of the data. Role-based access control is another common policy implemented to manage who has access to what data within the data lake. It allows organizations to assign specific roles to individuals or groups, and access is granted based on these roles, ensuring the right people have access to the right data. Data retention and archival policies guide how long data should be retained in the data lake and when it should be archived or deleted. These policies are often formulated based on legal requirements, business needs, and data's relevance and usefulness. Finally, metadata management policies are crucial in data lakes. Metadata, data about data, needs to be effectively managed to maintain the data lake's navigability and the usability. These policies ensure that the metadata is accurately captured, stored, and updated, enabling users to easily locate and understand the data within the data lake. Each of these policies plays a pivotal role in managing the complexity of data lakes and ensuring that they deliver value to the organization. A noteworthy instance is Coca-Cola Andina, a major bottler for the Coca-Cola company in Latin America. They deployed a data lake solution on AWS platform, helping them transform their business operations. With a vast amount of data collected from disparate sources, Coca-Cola Andina faced the challenge of extracting valuable insights in a timely manner. The data lake solution enabled them to integrate, clean, and analyze data, leading to significantly faster decision-making processes. The system could process large amounts of data in real time, allowing Coca-Cola Andina to quickly identify sales trends and effectively plan their logistics, ultimately increasing their operational efficiency. The implementation of the data lake brought about a significant uptick to the productivity of the analytics team, showing an 80% increase. This was largely due to the system's ability to consolidate disparate data, accounting for 95% of business data into a single accessible repository. Traditionally, disparate data silos were unified, providing a comprehensive data view of operations and customer interactions across various business areas. Their data lake's infrastructure was designed to support advanced capabilities such as artificial intelligence and machine learning. These technologies harness the power of consolidated data, enabling the identification and prediction of trends, which led to more informed business strategies and decisions. The use of AI and ML also automated routine tasks, freeing up the analytics team to focus on strategic high-value tasks. Another advantage was the reliability and the unity of data. Prior to the data lake, teams had to deal with fragmented and often inconsistent data, which complicated decision-making processes. The data lake allowed for more reliable data-driven decisions based on unified and consistent data, which instilled confidence in the strategic directions chosen. The impact on the bottom line was evident. The efficiencies gained, the adoption of AI and ML, and the ability to make decisions based on reliable, unified data all contributed to significant increased profitability. The data lake solution proved to be a crucial component in strengthening the operational effectiveness and the financial performance of the business. In this transformative journey, AWS played a pivotal role, where the storage of data, Amazon S3 was utilized, offering highly scalable, secure, and durable storage infrastructure. It handled the data ingestion with aplomb, regardless of scale, and was able to accommodate the rapidly growing volumes of data in the business. For the consumer layer, AWS QuickSight and Athena were employed. QuickSight's robust BI service made it easy to create and publish interactive dashboards that include insights, while Athena's serverless interactive query service made it simple to analyze data in S3 using standard SQL, thus allowing for real-time data explorations and quickly generating more insightful insights. The advanced AI capabilities were harnessed using AWS Personalize and SageMaker. Personalize was used to create individualized recommendations, enhancing the customer experience and promoting retention and reuse. SageMaker, with its ability to build, train, and deploy ML models quickly, was instrumental in predictive analysis. AWS Lambda provided the serverless compute capability, allowing the business to run applications and services without thinking about servers. This has not only reduced the operational complexity, but also led to significant cost savings. For data storage, depending on the scenario, DynamoDB, DocumentDB, and Redshift were employed. DynamoDB provided a key value database with low latency at any scale. DocumentDB offered a fast, scalable, highly available, and fully managed document database service that supports MongoDB workloads. And Redshift, with its powerful, fully managed, petabyte scale data warehouse service, made it simple and cost efficient to analyze all the data using existing business intelligence tools. AWS's comprehensive suite of services delivered a powerful and flexible solution that was instrumental in transforming the business data operations. As technology continues to evolve, so does the field of data storage and management. Let's discuss some future trends that data scientists should keep an eye on. Of course, cloud-based data lakes are expected to become more prevalent, offering increased scalability, flexibility, and cost-effectiveness. Additionally, advancements in machine learning and artificial intelligence will continue to enhance data lake capabilities, enabling more sophisticated data processing and analysis. You just have to look at the investment that Databricks are making in LLMs and the way that you interact with data inside of their platform to see where their strategy is leading them. Furthermore, as organizations become increasingly data-driven, the demand for professionals with expertise in data storage and management will continue to grow. Data scientists should stay updated with the latest trends and technologies to remain at the forefront of the field. In terms of job prospects, a recent report from LinkedIn ranked data scientists as the most promising job in America. More specifically, the job market for professionals with expertise in data lakes is also on the rise. According to a study by Markets and Markets, the data lake market size is expected to grow from $7.9 billion US in 2021 to $20.1 billion in 2025, which is a sizable increase in data lake investment at a compound annual growth rate of 20.6% during the forecast period. This demand for data lake expertise will likely fuel job growth in the field. And that brings us to the end of today's episode on setting up data lake for efficient data storage. We've explored the definition of a data lake, the steps involved in its setup, data lake terminology, overcoming challenges, real-world examples, and future trends. We hope this episode has provided valuable insights for data scientists seeking to optimize their data storage practices. Remember, setting up a data lake requires careful planning, robust infrastructure, and a deep understanding of your organization's specific needs. By implementing best practices, you can harness the power of data lakes to unlock valuable insights and drive innovation. If you enjoyed this episode, be sure to subscribe to the Data Science Dossier Unwrapped for more in-depth discussions on all things data. And as always, we welcome your feedback and questions. Stay tuned for our next episode where we'll dive into the world of data analytics. Until then, keep exploring, keep analyzing, and keep harnessing the power of data.